GAM 575, Game Engine Programming 2. This is the final project. So I have two programs, an FBX converter. It takes out all the mesh data, it takes out the animation data, and then the second project I have extracts that, the, uh, those archives, and builds skeletons, and they animate based on the FBXs. So here's the FBX. It extracts meshes. You can import textures into it, hierarchy information, and animation data. And you can run it through a batch file. So here it is right here, and it does all the work for you. To get it to work as it is, this is all checked in. First thing you need to do is extract all of the FBX data here, and I have three meshes and five animations right now. You run this, and it should go through everything and parse everything out. And oops. And here are your Azul files for the three meshes. And so that's how that works. And it's real simple, real easy, and it will generate all the data you need. And yeah, so it was using the FBX SDK, and it was pretty straightforward. And everything has a unique key. So if you look at this right here, everything has a unique name, and it's hashed, and that's how I am able to pull the specific resources from these archive files. So here's the FBX animator. So I took the old engine that I made in the first game engine program, and I added the animation parts to it. So it can now take a FBX file and give that unique name, and it can actually generate the mesh for you. Like right here, the Teddy Zool file, and this is the name of its mesh. And if you do that, it will work. And here's all the hierarchy model. Or, I'm sorry, the animation models are all here, and the hierarchy models are here. And let me run this. So here they are. This is so this mesh right here, the boxer, the running boxer, and this boxer, they're the same skeletal hierarchy, and they have different animations, as you can see. This is the teddy bear walking, and I think this one is Astral Boy, like moving. That's how the FBX was. And so that's that. Um, so I made a game object animation file, and so now the way it works, everything is there's a local matrix and a world matrix. So everything locally to that node is processed and calculated, and then based on the parent, the world is calculated. And so that's how that works. And it's using slurp and lerp for the animation, so they're smooth and not choppy. And then that I got that working. And so every time, yeah, right here, every time an update happens. Oh, actually, well, yeah. Every time an update happens, the time of the last frame is actually going to. I created this d time, and the time uh, from the previous frame goes into this update function. And I have a constant multiplied to it, and this constant is, you can change this constant to a negative number, a positive number, a big number, small number, and that will affect the speed and the direction of the animation. So for an example, if I want to pause the animations, all I have to do is hit the space bar. Everything's paused. If I want to go backwards, I hit the minus key. Now everything's going backwards. If I want to go forwards, I hit the plus key. Everything's going forwards. And the more you hit it, the faster it goes. So that's how that works. And that was really simple because of how I had everything set up. So, and it was pretty simple to get working. And I guess that's about it. So that's the final assignment, the skeletal animation system.